Okay, this is the second of the 3 videos for today's lesson. Right now, we are going to go over the Unit 7, Day 7 warm-up. I want you to try the warm-up first before you just immediately jump to watching this video. So please take a moment right now, if you haven't done the warm-up, to pause the video and move into the warm-up. Okay, hopefully you took a chance to try this. If you were looking at this and you were really just, I don't know what to do, I don't know where to go, right? These are like problems 16 through 22 on the homework, which I said we may have struggled with because of how many properties there are. We are asked to name each type of quadrilateral, parallelogram, rectangle, rhombus, and square. Those are the only 4 that we've seen so far for which the statement is true. 1. Both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. That's all parallelograms. That includes rhombus, rectangle, square. Doesn't matter how you draw them, right? If I have a parallelogram, which maybe I'll draw that a little better. If we have a parallelogram here, I know it is always true that those opposite angles are congruent. Whoops. That these opposite angles are congruent as well. I know that is always true. That always has to be true anytime we're looking at a parallelogram. Is a rhombus a parallelogram? Yes. Is a rectangle a parallelogram? Yes. Is a square a parallelogram? Yes. So it has to be true for all 3. The quadrilateral is equilateral. Equilateral means equal sides. All the sides are equal. That is true for a rhombus or a square. It is always true for a rhombus. For a square, it is only true, if every angle is 90 degrees, right? That's the only way it could be a square. So it's a rhombus where every angle is 90 degrees. That's what a square is. So if our quadrilateral is equilateral and all the sides are congruent, we can either be looking at a rhombus or a square. Okay, looking at the last 2. Given rhombus, MNOP, find the measure of angle NPO. Well, let's just highlight this angle first, right? NPO, let's see where that's at. NPO. Oh, we're talking about this angle right here. Maybe I'll highlight it real quick. We want to find that angle there. We only know this angle, but we know it's a rhombus. What do we know about rhombuses? That the diagonals bisect the opposite angles. So angle N is being bisected. Angle M is being bisected. Angle O is being bisected. And angle P is being bisected. Answer this one in your head. When you see the word bisect, what do you think? Hopefully the answer was cut in half. Cut in half. That's what bisect means. So if this angle is 48 degrees, then the other part of that angle is also going to be 48 degrees. That means the entire angle, angle N, is going to be 96 degrees, the entire thing. What do we know about opposite angles? Opposite angles are congruent. So if this whole angle was 96, that means this whole angle has to be 96. Well, this angle is also being bisected. So what does that tell us? It's cut in half. So what should this angle be? 48 degrees. Right, so angle NPO, what we were looking for, is 48 degrees because opposite angles are bisected and opposite angles are congruent. Actually, I'll just leave that up. Why not? Okay. Given rectangle QRST, find the lengths of the diagonal given that RT is 5x minus 1. So that's RT. The whole thing is 5x minus 1. And SQ, the whole thing, is 2x plus 17. Well, what do we know about the diagonals of a rectangle? The property that we have is that the diagonals are congruent. Are the diagonals bisected? Yes, because it's a parallelogram. But does that help us with this problem? No, it doesn't. What helps us is knowing that in a rectangle, those two diagonals have to be congruent. What do we do with congruent things? You set them equal to each other. 5x minus 1 is equal to 2x plus 17. Should get x is equal to 6. But we're not done. We were asked to find the lengths of the diagonals. Do I need to substitute it into both? No, it's going to be the same. It doesn't matter. But you should get that RT is 29 and SQ is 29. If you want to find both of them, be my guest, right? And see that they're the same? Sure, that's fine. But you don't have to. Hopefully you took the time to try this first yourself. If you have any questions, please let me know. But we are now going to move on to the notes. So please see the next video for the notes.